Imagine this. You're reading this right now, light bouncing off your screen and into your eyes. But what if, in the next second, light just stopped? Not dimmed, not faded, just froze in place, like someone hit pause on the universe itself. Your screen would vanish, the sun would blink out, and within minutes, everything you know would unravel in ways so catastrophic, so absolutely terrifying, that even saying the world would end doesn't quite capture it. Because when light stops, physics itself breaks. And today, we're going to walk through exactly what that nightmare would look like. Second by second, minute by minute, until there's nothing left. This isn't just about darkness. This is about the complete collapse of reality as we understand it. And trust me, by the end of this video, you're going to see light in a way you never have before. So if you're ready to explore one of the most mind-bending scenarios in all of physics, hit that subscribe button right now, because Physics Decoded is about to take you on a journey to the edge of existence itself. Let's start with the first millisecond. Light stops moving. Right away, you'd notice something wrong, but your brain wouldn't be able to process what. See, vision doesn't work the way most people think. You're not seeing things in real time. You're seeing light that bounced off objects and traveled to your eyes. When light stops, that final image, whatever photons were already on their way to your retina, would be the last thing you'd ever see. Then, instant blindness. Not the blackness you experience when you close your eyes. Something far stranger. Because even that blackness requires the absence of light hitting your eyes. This would be nothing. Your visual cortex would simply have no input to process. But here's where it gets really wild. You wouldn't just go blind. Every screen, every light bulb, every star in the sky would simultaneously disappear from view. Not because they stopped working, but because the light they're emitting isn't moving anymore. It's frozen in space, suspended between the source and your eyes. The sun would vanish from the sky 8 minutes and 20 seconds before the actual catastrophe begins on Earth, because that's how long light takes to travel from the sun to us. For those 8 minutes, Earth would still be warm, still be receiving the last of the sun's heat that was already on its way. Then the cold would hit. Without new sunlight arriving, Earth's temperature would plummet. Not slowly, like a winter night. Catastrophically, within a week, the average surface temperature would drop below freezing everywhere on the planet. Within a month, we'd be looking at temperatures around -100 degrees Fahrenheit. The oceans would begin to freeze from the top down, starting with a thin layer of ice that would grow thicker by the day. But the ocean freezing would actually be one of the slower disasters, because something much worse would happen first. Plants would die within days. Every plant on Earth, from the smallest blade of grass to the tallest redwood, depends on photosynthesis. No light moving means no photosynthesis. No photosynthesis means no oxygen production. Now, we wouldn't suffocate immediately, because there's plenty of oxygen already in the atmosphere, but the food chain would collapse almost instantly. Herbivores would starve within weeks as vegetation died off. Carnivores would follow shortly after. Humanity would face a famine unlike anything in history. And we'd be trying to survive this in complete, total darkness, in freezing temperatures that would make Antarctica look tropical. But wait, we've been assuming that only light stops, right? That everything else keeps working normally. Let's talk about why that assumption might be the biggest mistake we could make. Because light isn't just light. Light is electromagnetic radiation. And electromagnetic radiation is how atoms hold together. It's how molecules bond. It's how chemistry happens. If light truly stopped moving, if photons could no longer propagate, then electromagnetic forces would cease to function. And that means matter itself would fall apart. Think about your body right now. You feel solid, right? You're sitting or standing, holding your shape. But you're actually mostly empty space. The reason you do just collapse into a cloud of atoms is because electromagnetic forces between electrons create what we call the Pauli exclusion principle. Electrons repel each other. That repulsion is mediated by virtual photons, particles of light constantly being exchanged between electrons. If light stops, those virtual photons stop. The electromagnetic force stops. And suddenly, there's nothing preventing every atom in your body from either flying apart or collapsing into itself. The entire planet would undergo something physicists might call quantum decoherence on a macro scale. Every chemical bond would break simultaneously. Water molecules would dissociate. The air would stop being air and become a soup of individual atoms. Your body, my body, every living thing, every solid object would cease to have structural integrity. We wouldn't freeze to death in the dark. We'd dissolve into atomic chaos in the first fraction of a second. Now, some of you physics fans out there might be thinking, hold on, what about the strong nuclear force? What about gravity? Those don't depend on photons, right? You'd be correct. The strong nuclear force, which holds protons and neutrons together in atomic nuclei, would still function. Gravity would still pull masses together. But here's the thing. Without electromagnetism, matter as we know it can't exist. Atoms would still have nuclei, sure, but without electrons in proper orbits, without chemical bonds, you don't have chemistry, you don't have biology, you don't have solid objects. You just have atomic nuclei floating in space, occasionally bumping into each other, held together internally by the strong force, but unable to form anything meaningful. Let me paint you an even stranger picture. What happens to the Earth itself? The planet is held together partly by gravity, yes, but also by the electromagnetic forces between atoms in rock, in metal, in the molten core. Without those forces, the structural integrity of the planet would fail. Earth wouldn't immediately explode, but it would begin to deform under its own gravity. The crust would crack and crumble, mountains would flatten, the core would shift. Over time, maybe hours, maybe days, Earth would reshape itself into a more spherical blob of loosely associated atomic nuclei, still held together by gravity but lacking any real structure. And the sun would be even more dramatic. The sun is a massive fusion reactor, crushing hydrogen atoms together with such force that they fuse into helium, releasing tremendous energy in the process. But that fusion process depends on electromagnetic interactions. Protons have positive charges, and they repel each other electromagnetically. It takes immense pressure and temperature to overcome that repulsion and get them close enough for the strong nuclear force to take over and fuse them. Without electromagnetism, there's no repulsion to overcome. But there's also no way for the fusion products to interact properly. The sun's fusion would cease, its internal pressure would drop, and without that pressure to counteract gravity, the sun would begin to collapse. Depending on the mass and the specifics of how physics breaks down in this scenario, the sun might collapse into a dense ball of atomic nuclei, or it might trigger some kind of catastrophic runaway collapse. Either way, it wouldn't be the sun anymore. It would be a dark, cold, dead remnant. Let's zoom back out to the cosmic scale for a moment, because if light stops moving everywhere in the universe, not just near Earth, the implications are almost beyond comprehension. Every star would go dark. Every galaxy would disappear from view. The cosmic microwave background radiation, the afterglow of the Big Bang that permeates all of space, would freeze in place. The universe would become a void of darkness, with matter slowly degrading into unstructured atomic nuclei, held together only by gravity and the strong nuclear force. Black holes would be one of the few things that might remain relatively unchanged. They don't emit light anyway, except for Hawking radiation, which is incredibly faint. But even Hawking radiation involves photons, so that would stop too. Black holes would become even more isolated, even more invisible than they already are. They'd still warp spacetime, still consume anything that got too close, but they'd do it in absolute, eternal darkness. Here's a question that might be bothering some of you. If light stops moving, what happens to information? In physics, information is often transmitted by light. The state of a distant star, the temperature of an object, the color of a surface, all of that is information carried by photons. If photons stop moving, does information stop propagating? In a very real sense, yes. The universe would become causally disconnected in a new and terrifying way. Events happening in one location couldn't influence events anywhere else, at least not through electromagnetic means. Gravity would still propagate, but gravitational waves also travel at the speed of light. So if light stops, maybe they stop too. The universe would fragment into isolated pockets of causality, each one unaware of the others. Now let's get philosophical for a second, because we need to talk about what it even means for light to stop. Light, photons, they don't experience time. From a photon's perspective, if it could have won, its journey from emission to absorption is instantaneous. It's created and destroyed in the same moment of its own reference frame. So what does it mean for something that doesn't experience time to stop moving through space? This is where the scenario breaks down into pure speculation, because we're talking about violating the fundamental structure of space-time itself. Einstein's theory of relativity tells us that space and time are woven together into a single fabric. The speed of light isn't just a speed limit for photons. It's the speed at which causality propagates. It's the conversion factor between space and time. If light stops, if that speed becomes zero, then the relationship between space and time collapses. Time itself might stop, or it might decouple from space in some bizarre way that we couldn't even conceptualize with our current physics. Some theoretical physicists have speculated about scenarios where the laws of physics themselves change, where fundamental constants like the speed of light could vary. These are called cosmological phase transitions, and they're thought to have possibly occurred in the very early universe. If the speed of light suddenly dropped to zero, it would be like a reverse phase transition, undoing the fundamental structure of reality. The universe wouldn't just become dark and cold. It would cease to be a universe in any recognizable sense. Let me bring this back to something a bit more concrete, something you can visualize. Imagine you're in a room when light stops. The last image you see is frozen on your retinas. Let's say you were looking at a window, at sunlight streaming through. That image would persist for a fraction of a second as your neurons fire one last time with the information they have. Then darkness. You'd feel the air around you, except the air would be falling apart at the molecular level. You'd try to breathe, but there'd be no oxygen molecules to inhale, just individual atoms. You'd try to move, but your muscles, which depend on chemical reactions, electrical signals transmitted by ions flowing through channels, all mediated by electromagnetic forces, would cease to function. Your consciousness, if it could persist even for a moment without functioning neurons, would experience something utterly alien. No sensory input, no body, just a brief flicker of awareness before the quantum states that make up your thoughts take a here and vanish. You wouldn't die in any conventional sense. You'd simply cease to be a coherent pattern of matter and energy. Here's something that really messes with my head. If this happened, if light truly stopped everywhere at once, there would be no one left to know it happened. No survivors, no witnesses, no records. The universe would transition from a state of complexity, of structure, of life and thought and meaning, to a state of maximum entropy and disorder, all in an instant. And because information couldn't propagate anymore, because light couldn't carry the news of this catastrophe from one place to another, each region of space would undergo this collapse in isolation, unaware that it was happening everywhere else too. But let's play devil's advocate for a moment. Is there any way anything could survive? Any loophole in the physics? Well, if we're being creative, we might imagine that some exotic form of matter that doesn't rely on electromagnetism could persist. Neutron stars, for example, are held together primarily by the strong nuclear force and gravity. They're so dense that the electromagnetic force is almost irrelevant to their structure. A neutron star might survive the stopping of light, continuing to exist as a dark, cold ball of neutrons. But it would be utterly lifeless, just a relic floating in the void. Similarly, if there are forms of dark matter that don't interact electromagnetically, they'd be unaffected. Dark matter doesn't emit, absorb, or reflect light anyway, so if light stops, dark matter wouldn't care. It would continue on, held together by gravity, forming the same large-scale structures it does now. But without normal matter, without stars and galaxies and planets, those dark matter structures would be invisible, intangible, meaningless. There's also the question of whether quantum mechanics itself would continue to function. Quantum mechanics describes the behavior of particles at the smaller scales, and it's deeply connected to the electromagnetic force. Wave functions, quantum superpositions, entanglement. A lot of these phenomena involve photons or electromagnetic interactions. If light stops, does quantum mechanics break down? Do particles stop behaving probabilistically and start behaving in some other way? Or does the entire quantum framework collapse, leaving us with something even more fundamental, or perhaps nothing at all? One of the most unsettling aspects of this scenario is the sheer totality of it. We can imagine other catastrophes, asteroid impacts, supervolcano eruptions, even the sun expanding into a red giant billions of years from now. Those are terrifying, but they're localized or gradual. Life might survive somewhere, or we might have time to escape, or at least understand what's happening. But light stopping is universal and instantaneous. There's no escaping it, no preparing for it, no understanding it before it's already over. And yet, here's the beautiful irony. The very fact that we can imagine this scenario, that we can think through the consequences, that we can use physics and mathematics to predict what would happen, is only possible because light is moving. Right now, photons are bouncing off the screen or page in front of you, carrying information to your eyes. Electrical signals, mediated by electromagnetic forces, are racing through your neurons, allowing you to think about light stopping. We exist in a universe where light moves, where causality flows, where structure and complexity are possible, and that's something worth appreciating. So what have we learned here today? We've learned that light is so much more than just illumination. It's the glue that holds matter together. It's the messenger that connects distant parts of the universe. It's the foundation of chemistry, biology, and ultimately, consciousness itself. Without light moving, there is no universe as we know it. There are no atoms, no molecules, no planets, no stars, no life. Just an empty, dark, structureless void, if even that. Before we wrap up, I want to hear from you. What part of this scenario scared you the most? Was it the instant blindness, the breakdown of matter, the total erasure of everything? Drop your thoughts in the comments below. And if this video made you think about physics in a new way, share it with someone who loves mind-bending science. Trust me, they'll thank you for it. Here's the thing about thought experiments like this. They remind us how finely tuned our universe really is. The speed of light isn't just some random number. It's a fundamental constant that makes everything else possible. Change it, stop it, break it, and reality itself unravels. We live in a universe governed by precise laws. Laws that allow for the existence of stars and planets, and against all odds, us. That's pretty incredible when you stop and think about it. So the next time you see light streaming through a window, or reflecting off water, or illuminating the night sky, remember what you learned today. That light isn't just pretty, it's essential. It's holding you together at the atomic level. It's allowing your eyes to see and your brain to think. It's connecting you to the rest of the universe in ways both obvious and profound. Light moving is what makes existence possible. Thanks for watching Physics Decoded. If you enjoyed diving deep into this impossible scenario with me, make sure you're subscribed because we've got more mind-blowing physics content coming your way. Hit that like button if you learned something new, and I'll see you in the next video, where we explore another corner of physics that'll make you question everything you thought you knew about reality. Until then, keep wondering, keep questioning, and never take the light for granted.